Okay, we're on to the final chapter, chapter 6, which is on financial mathematics. So talk about real world. When am I ever going to use this, people? There'll be none of that complaining in this chapter. And I think this first section, 6.1, will be of particular interest to you. Dad joke right there. Anyway, 6.1's on simple interest and compound interest. So you're probably familiar with interest already, but the way I've defined it here, it's the amount of money earned on an investment or paid on a loan. So for this section, we're going to focus on investments, you putting money into the bank, for example. And there's two types of interest. There's simple interest, which we're going to talk about first, and there's compound interest, which is on the back side of this page. So just quickly to do with interest, as you know, you put money in the bank, and then the bank will pay you some money, some interest for having your money in the bank. Now, why do they do that? Why do they give you that money? What's in it for the bank? They're just such nice people, aren't they? The bank giving you money just for looking after your money. No, what happens is they take your money and then they lend it out to other people at a higher interest rate. So maybe they're paying you 3 or 4% of what you've put into the bank. They're giving you, for every $100, they're giving you $3 back. Then they take your money, that $100, they lend it out to someone for their mortgage on their house or something, and they charge them 9 or 10%. So they're making more money that way. Oh, those banks. Wouldn't it be nice to have the rules stacked in your favor like that? Okay, so simple interest. Is interest that's based on the principal and the interest rate. What's the principal? Here's the principal. The principal is the original amount of money invested or loaned. So you go into the bank and you open up a savings account and you put $2,000 in there. That's your principal. That's how much you started with. The interest rate is the agreement that the bank has with you with how much they're going to pay you annually for having that money in there. And usually what we're talking about is a fixed interest rate. And what we mean by fixed is it doesn't change. It's guaranteed not to change during the term of the investment. Now, this isn't always the same. Sometimes with mortgages and stuff, you have a variable interest rate, and it can change depending on the market. But to start, let's consider fixed interest rate. Term. Term is the contracted duration of the investment. Now, there's not always a contracted duration. You put something in a savings account, and there's no real contract about how long it's going to be in there. But if you buy something like a GIC, bonds perhaps or something, then there's usually a contracted duration. So there's an amount of time you promise that you're going to keep the money in there, and that's called the term. Now, you can still get the money out early usually, but then you get penalties. You have to pay back some of the money because you didn't do what you said you were going to do. Along with term is maturity. Maturity is the contracted end date of an investment. So, you say, for example, this bond is going to reach maturity in 2020. So that's the time when the term ends. And per annum. Per annum is a fancy way of saying per year. So you might even see something like this, 4% per A. And believe it or not, that means per annum or per year. Okay, so the one thing I've overlooked here, or I've skipped, is the formula for simple interest, which is right here. I equals PRT. So you can probably figure out what most, if not all, these stand for. The I is obviously interest. Do I need to write that down? Interest. I mean, come on. The P, you probably now know, is the principal. Principal. The R, I'll write the R here. The R is the annual rate of interest. And this is important. With that R value, it must be expressed as a decimal. Okay, so usually when you talk about it, you talk about it as a percent, 5%, 12%, but you need to change that into a decimal. And T is equal to time. So this makes sense. If you want to get lots of interest, there's three things you can do. You can put lots of money in the bank, so that's a big principle. You can get a high rate of interest. It's not easy to do, but you can get a high rate of interest. That'll increase the amount of interest you get. Or you can keep it in there for a longer time. And this is kind of the secret to making money. A lot of experts say this is, if you can really understand this about the T part of this equation, you can make a lot of money, but it takes a lot of time. Alright, so, one I skipped, the future value. The future value is the amount, A that an investment will be worth after a specific period of time. Now, if you think of it, if you start with the principal, right, that's how much you started with, and then you gain some interest, what's your future value going to be equal to? Pretty simple formula. It's going to be A, the future value, is equal to the principal, what you started with, and then the interest. And we already said the formula for interest was PRT. So I'll put another one of the fancy rectangles around there. Okay, so two formulas there. So Marty invested in a 2,500 guaranteed investment certificate. So this is one of these things where you buy it, you're guaranteed a certain interest rate, and then it's going to mature after 10 years, it says here. So it's pretty low interest here, only 2.5%, simple interest. It's paid annually with a term of 10 years. Find the interest accumulated and the future value of his investment at maturity. So we're going to use the simple interest formula, P times R times T. So what's the principal? How much did Marty put in? 2,500. What's the interest rate? It's 2.5%, but remember we have to express it as a decimal. So with to change a percent into a decimal, you move the decimal over 2 to the left. So you're taking 2.5 and you're moving that decimal 2 spots to the left. There's my decimal now. What goes in this spot right here? A 0. So what you get is 0.025. I'm hoping we're all okay with that. So that's $2,500. Our interest rate is 0.025, and the time, how long does it take for this to mature? 10 years. So we're going to multiply it by 10. So we're figuring out how much interest Marty's going to have after 10 years. And if you multiply that out, you're going to end up with $625 in interest. Now there's actually a second question here, isn't there? The second question is, what's the future value? So to get the future value, we use this formula, A equals P plus PRT. But remember, this PRT is exactly the same as I. So it's actually like P plus I. We know what P is. P was the 2,500, the principal. And we just figured out what I was. I is 625, the interest. If we add those together, we're going to get $3,125 as our total amount. So there's simple interest. It's actually not as common, I would say, and it's definitely not as powerful as what we're going to talk about now, which is compound interest. So what's the difference with compound interest? The difference is, with compound interest, interest is earned on both the principal, just like before, but also on the previously earned interest. With simple interest, like we talked about before, let's say someone puts $100 in the bank. I'll just write this down so we can remember this. So simple interest, I put $100 in the bank, and let's say you get 5% per year of interest. So after the first year of having your $100 in the bank, you get 5% in interest, so you made $5. Great, $5 in interest. Now in the second year, you get 5% again. You get 5% of how much? Of $100, you get another $5. The third year, you get 5% of $100, you get another $5. It stays the same year after year after year. Compound interest is not like that. So let's say we had the same situation. You put $100 in the bank, and the first year, and again, you get 5% interest. So after the first year, you would again get $5 in interest. But now, in the second year, you're going to get 5% of not 100, you're going to get 5% of 105. Now, I know that doesn't sound a lot different. Let's say 5% of 105 is 525, I believe. Wow, you made an extra quarter. But we're talking about very small amounts of money here, and we're talking about very small amounts of time. What we'll do, we'll probably do some investigations in class. You'll see how quickly this compound interest can increase in value. Basically, rather than having linear growth like you do in simple interest, you can end up getting some exponential growth, and that is pretty darn powerful. So here's the formula, A, and remember that A was the future value, so it's a little bit different in this formula because this one isn't going to tell you directly the interest, it's going to tell you the future value, is equal to P, well you know what that is, that's the principal. And then times 1 plus I, this is your interest rate, and again it needs to be as a decimal. So I'll put in brackets decimal again. I can't write today for some reason. And N, this is something new we haven't looked at yet. N is the number of years that you're keeping that investment in the bank or wherever. Okay, so this question should look familiar. There's only two differences. One difference is the name, Rena. In the previous page, we had, what was his name, Martin or something? Marty. But same amount. Rena's got 2,500. She's put it in a GIC, just like Marty did. Hers is 2.5%, just like his, but hers is compound interest. Marty's was simple interest. We're going to see the difference with compound interest. Just like with Marty, it's paid annually and it matures after 10 years. We're going to find, just like before, the interest accumulated and the future value. Okay, we're actually going to do it in the opposite order than we did before because this equation has solves for A. So A equals P, what was the principal? 2,500. 1 plus I, so again, our I is 2.5%, but we need to change it to a decimal, so it's 0.025. And the number of years, 10 years. So we're going to solve that. So, you'd probably do this in a calculator, and just to be sure you do it in the right order, first you'd add the stuff in the brackets together, so you get 1.025 to the 10th. Now, make sure at this point that you do the exponent first. Remember, BEDMAS, you have to do exponents before multiplying. Do not do 2,500 times 1.025. You have to go 1.025 to the 10th power, and then multiply that by 2,500. And if you do that, you'll get an amount $3,200.21. That's our final amount. What if I want to know how much interest I made? Well, to get the interest, you're going to get your final amount. You subtract how much principal you had. That will give you the interest. So my final amount was 3,221. My principal, the original amount, was 2,500. And if you do that, you're going to end up with $700.21. Okay, so again, this is my interest, and this was the final amount here. So let's compare that. Again, this isn't going to shock and amaze you and change your life altogether, but $700 here, and in the previous case, it was $625. So Rena made 75 extra dollars, but it took 10 years to do that. I mean, doesn't sound that big of a deal at all. But remember, she made 75 extra dollars by doing nothing. The only thing different was it was compounded. If you were talking about bigger amounts of money, I mean, that's a fair bit of money, but I will say this is a fairly low interest rate. If you're talking about bigger amounts of money, if you're talking about higher interest rates, if you're talking about longer term lengths of time, this can go up very, very high. All right, now to do these things, you can also use the TVM solver. That stands for time value of money, I think. I've actually never knew what it was standing for. I looked it up and that's what I found. And you can use this on the TI-83 calculators. You can also use it online. So I'll just quickly show you on the calculator. Okay, so here we go. You see that it says finance right here? On this particular one, this is TI-83. I think the TI-83 Plus is different. But in this one, you want to access that finance button. So you hit second, and then this X to the -1. You end up getting this. You see the first one there's TVM solver. That's what we want. So I hit 1, and come on, come on. There it is. And then you get all this information. You're going to enter in the information. So let's answer the same question we just did using the TI-83, and we should get the same question. So what N stands for is the number of payment periods. And in other words, number of times you're going to get interest. Well, in that last question we just did, remember it was 10 years. You're going to get interest 10 times. So I put 10. The percentage, I percentage, that's the interest rate. Now in the T83 you don't need to put as a decimal. So remember in that last question we did, the interest rate was 2.5%, so I put 2.5. PV, PV stands for present value or initial value. So it's like the amount of money you started with. What does that sound a lot like? That sounds like the principal. That's exactly what it is. It's the principal. So we're going to put our principal in there, which was 2,500, but you're actually going to put negative 2,500 because you've given that money up to the bank. That's not money in your pocket. That's money that's going out to the bank in a sense, right? So we're going to put negative. Remember, this is a negative here, not this one here. So negative 2,500. I'm going to use the keyboard. It's just so annoying. Okay, payments. Payments would be if like you're making other payments through the year, putting money into the bank and stuff. We might do more complicated questions like that later, but we're not going to do that today. This is always going to be 0. Future value, that's what we want to know. We'll just leave that 0 for now. I'll show you why in a second. PY is kind of a strange one. It's the number of payments you make per year. Now, we're not making any payments per year, but this is really messed up with the TI-83 for some reason. That number there should just always be the same as the bottom number. So just make that the rule. Whatever you make C of Y, put the same number for P of Y. So what's C of Y? It's the number of compounding periods per year. So what in our question, we said that you get interest once per year, but that's not always the case. In other accounts, you can get payments once a month, 4 times a year, once a week, even once a day, some things. But for us, it's once a year, so we just leave that as 1. Okay, the bottom one is payment. Are you going to get the interest in a sense? Are you going to get that at the end of the year or at the beginning? It's always going to be the end for us, unless it says otherwise, but it's almost always going to be end. Okay, we want to know the future value. So what you do is you go back up to future value, you put your cursor there. You can put any value in there you want, but I'll just leave it at 0. And then you're going to hit alpha and the enter button, because you see that alpha button makes solve. So we're going to solve this. And when I do that, I get my amount. It's positive, because this is actually money that's now available to me, 3,200.21136. In other words, 3,221 cents. Is that the number we got here? Absolutely, here it is here, 3,221 cents. So the TVM solver can be used to do this. You can also use it online. I found this one here. Check it out up here, zenwealth.com, business finance online, blah, 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 blah. There it all is. Same thing, you could put in your information here. So the present value was negative 2,500. The rate was 2.5%. The number of periods was 10 years, right? We're getting it annually, not semi-annually or quarterly. We're getting annual interest. The future value we want to know, and the payments, none. There's no payments, so we'll just put 0 there. Now we want to know future value, so you click on future value, and there's that amount again, 3,221. Okay, so there's different ways to do this, either on the TI-83 or the internet, so find one that works for you. Okay, finishing up here with the Rule 72. Rule 72, it's way too complicated to explain why this is the case, but it is the case that the length of time for an investment to double is approximately, not exactly, but it's approximately equal to 72 divided by the annual interest rate. So if you want to know how long it takes to get twice as much money, right? If I put $3,000 in the bank and I want to know how long is it going to take until I have $6,000 in the bank, twice as much money. Basically what you can do to get an estimate of the number of years is you take the number 72 and you divide it by your interest rate. So if your interest rate was 10, you go 72 divided by 10, 7.2. If your interest rate was 6%, 72 divided by 6, 12. It would take 12 years in order to double. Okay, the other way you could arrange this question is if you know the annual interest rate and the number of years, those two things should multiply together and get approximately 72. Again, these probably shouldn't be equals, these should be approximate, those wavy equals. So let's do this last question. Estimate how long an investment of $2,000 would take to double if it earns 8% compounded annually. How close is your estimate to the actual value? So let's get our estimate. We want to use this formula because we want the number of years. Now, interesting about this, which piece of information in the question do we actually not need? The 2,000. It doesn't matter what the amount is. Whether you put $2 in there, 2,000, 2 million, it's always going to take the same amount of time to double if you have the same interest rate. So the way we figured out is we do 72, we divide it by the annual interest rate, which was 8%, and we keep it as a percent. And if you do that, you get 9. So we're saying it's going to be approximately 9 years. Now, let's see how accurate we were. Let's use our TVM solver and see how accurate we are. Let's use the one on the computer. I think it's faster. So our present value, it says we're going to put in $2,000, right? And what we want for a future value then, remember this is negative because we're lending that to the bank in a sense, but we want to have access to it later, want it to be our money, so we want later to have positive $4,000. What we don't know is the periods. We don't know how long it's going to take, but we do know the rate. The rate in this question was 8%. There's no payments. It's annual, so what we want to figure out is periods. We click period and we get 9.01. Wow, so the actual is 9.01 years, and we got 9 years. That's pretty awesome. 0.01, well, 365 days times 0.01 is 3.65, 4 days basically. We were within 4 days of the right answer. That's pretty darn impressive. All right, there's our start for finances. I hope that you're inspired to go and save money.